see me, they're just going to hear us talking through all the stuff that we need to do. And yesterday I made a note to myself that we did not get through this last one here. C. Did the rest of it. Didn't get to that. So you tuck that home and school communication form away, and we'll talk about C. So yesterday with the properties, we were talking about, you know, if you want to multiply similar bases, you add the exponents. So it just makes sense that if you got multiply, and you're talking about division, and those are inverses of each other, that you should basically do the opposite thing. So if multiply means add, then divide means subtract. That's what we need to do. So for C, I look at this and I think, well, I'm supposed to divide 4 by what? There's nothing there. Well, if there's not a number down here, what is it? It's 1, because there's 1, a to the 5th, b, c to the 3rd here. There's a 1. So remember, number parts are separate. You do what you know you're supposed to do for numbers. So 4 divided by 1 is going to be 4. And we know we have to subtract the exponents to divide. Well, little imaginary 1 there as well. So 1 minus 5, that's going to be negative 4. I go to my b's. Here's a 6. Here's a 1. 6 minus 1, 5. B to the 5th power. Go to my c's. 3 minus 3. That's 0. What's anything to the 0 power? Look back up at the box if you need to. What's anything to the 0 power? 1. I'm not even going to bother writing that down. I don't need that. So these two generally make people a little squeamish. It's like, can I do that? If I do 3 minus 3, I get 0, and that's just a 1. Yeah, that's by definition has to happen. Now, I don't think I'm quite done. What's wrong with that? Negatives. Can't leave that there. So I remember, anything can be written as a fraction by slapping a 1 below it. Anything. So now, if negative powers are for reciprocals, if something's on the top, it's going to go to the bottom. And if something's on the bottom and it's negative, it's going to go to the top. But this is 4 to the 1st. That's not going anywhere. That doesn't have a negative power. This is, that's negative. But this one's not going anywhere either because that's a positive 5. So on the top, I'm still going to have the 4 and the b to the 5th. But now on the bottom, just that negative exponent. So that'll become positive, and that'll make me 8 to the 4th on the bottom there. So this little concept bite that we went through is supposed to make us start thinking in terms of powers, because we're pretty used to things like square roots, and even sometimes in some of the problems we've been doing, we've been using cube root, and it's like, oh, I can do that. But what about when it's 4th root, 5th root, and 6th root? And that's our objective today, to start thinking in terms of roots. You know, not just square root, not just cube root, but any root that we have. So, get that packet open, and we will start chapter 6. Woo-hoo-hoo! Everyone cheering. All right, chapter 6, radical functions and rational exponents. The whole chapter is about going a little bit farther than we had before with math. Instead of saying, okay, I know in exponential, they taught us to take the square root of 5. Well, you can't really do that because there isn't any number that's going to work out nice. You know, you could put it on a graphing calculator and get the square root of 5 as a nasty decimal. And I also know that in exponential, if we had this, we'd add 4, and then we'd take the square root, and then we had to remember to do the plus or minus 2 thing, because, you know, when you take square roots, that's what happens. And you just did that because they told you to do that, which is unfortunate, because there's a why behind this. But when you're in the 9th grade, sometimes you can't understand the why. Here's the why. When you write square root, there is a little imaginary 2 inside that little b. And what that little 2 tells you is we're trying to find the number that if we put it in these 2 slots and multiplied it together would give us that. That's what it's saying. if we figure out what this is, it needs to go in both these slots, and if I multiply them, it better give me 5. So, if I find the square root of 5 on my graphing calculator, it's going to be nasty. Second square root of 5. Boy, 2.236067977. Well, if that's right, that means when I take that times itself, 2.236067977, I should get 5 or something close, because this is a nasty one and the calculator rounded the answer. Really close to 5. Now it works perfectly in a situation like this because we're like, well, yeah, of course, the square root of 4, I could put positive 2 in each one of these, or I could put negative 2 in each one of these slots. Those will give me 4. You know, makes sense. So that little imaginary 2, where'd it go? Why don't we see it? Because square root is the most common root that people take. That's the one where we don't put it. And to tell you why that happens, we don't write a 1 in front of an x every time we know it's 1x, because it's just silly. Part of simplifying is knowing I don't need that. And it's the same thing with square root. We don't really need it because square root is the most often used. But when we want to take cubed root, fourth root, or fifth root, we need that little number in the v, and that little number in the v is called an index. So what we're going to do today is we're going to start talking about, square roots again, because we don't want to lose track of what we already know. But what if that little number inside the v changes? And we're going to try to think in terms of, okay, I've got slots I need to fill. What number would make that work? So roots and radical expressions are objective to find the nth roots. That means any root. N could be any integer. Find the nth roots. In fact, we're just going to use mostly natural numbers, which are going to be positives when we talk about nth roots. In the middle here, middle of the page, you see power equation. X cubed equals 8. Hopefully, you're looking at that and saying, that's wrong. See that? That's wrong. Because in chapter 5, we said, this is a degree 3 polynomial. It's supposed to have 3 answers. So I need to move the 8 over, and I need to factor that bugger so I can find all of the solutions, all 3 of them. I don't just want 1, not in this chapter. In this chapter, we're going to focus on just the real solutions. Where does this cross the x-axis? It absolutely crosses the x-axis at 2. So instead of all the factoring that we had to do before, now we're going to say, hey, I'm just going to take the cubed root of both sides, and I'm going to get the real answer. Cubed root of 8. So you think to yourself, something small enough that if I put it in these 3 slots and multiply it together would give me 8. Well, it can't be 1. 1 times 1 times 1 is 1. So next one I'll try is 2. 2 times 2 times, oh, there it is. It's 2. And you think through those little pieces to help you figure out that that's the cubed root of 8. We've got it. Now, is there a possibility that it could have been negative 2 in those 3 slots? What's wrong with that thing? You're shaking your heads. Why not? Jackson, why not? So if we have an odd root, if we take a cubed root, a fifth root, a seventh root, there's only one answer. And that's because it gives us a different answer if we have 3 slots to fill with a positive versus a negative answer. So if we take an even root, we're always going to have to put plus or minus. We're used to that. Square root is plus or minus. Fourth root will be plus or minus. But not an odd root. An odd root will only have the one solution. So down here it says, corresponding to every power there is a root. Yeah, you should have learned this a long time ago. Whatever we can do forwards in math, we have to do backwards. So if we're going to say 5 to the third is 125, there has to be a way to undo that and bring it back. And that's part of math. Whatever you show people, hey, look at this, this really works. Their first question, if they know anything about math, is, so how are you going to undo that? How are you going to get rid of it? Because what you do, you have to be able to undo. So if we have 5 squared is 25, thinking backwards, we'd say, well, the square root of 25 is 5, or 5 is the square root of 25. Just change the order. And if this is 5 to the third equals 125, 5 would have to be a cube root of 125 in order to make that work. And it is. If you put 5 times 5 times 5, you will get 125. It's going to work. 5 to the fourth is 625. Yeah, that's going to take us a little while to catch on to. You know, 5 to the third is 125. We saw that a lot when we did our sum and difference of two cubes. So we're used to that. Fourth power, that's going to take us a little while. So this would be 5 is the fourth root of 625. And then 5 to the fifth, 3125. We're rarely going to go that high. You know, it's just one of those things we need to know. Hey, it's there. It's the fifth root. So 5 is the fifth root of 3,125. And we're going to talk about some ways to get your brain to wrap itself around this whole power situation and how you can kind of think through what they would be. Because that's the best way to do these problems, is to use your brain power and think through them. I am going to show you that your calculator will do some of these roots as well, but that's a backup plan. You know, in Algebra 2, we want you to show the algebra first, and then the backup plan is the graphing calculator. So, down here. That's a big box. That's got a lot of gunk in it. It says if a to the n equals b. Okay, a to the n equals b. Oh, I should mention, those that didn't have me first semester, you see how there's lines over on the right-hand side? Sometimes I write stuff like this, and when I do it, you go, oh gosh, that makes perfect sense. You should write that down on those lines so that when you look at your notes later, you're going, oh, yeah, now I remember what she was talking about when she did that. So what we're saying here is, what if you wanted a all by itself? Well, you would have to take the nth root of both sides, because what we do to one side, we have to do to the other. And that would give you a equals the nth root of b. Forwards and backwards. If we can write it as a power, we need to be able to write it as a root and go both ways. So if a to the n equals b, with a and b real numbers, and n is a positive integer, then a is called an nth root of b. And yeah, I know that's really generic, because they're trying to get us to understand that whatever root we're taking, there are general rules for those roots. The first is this. If this is 3, 5, 7, 9, 11, any odd number, you get one answer. There's only one. So there's one real nth root of b, and it's denoted in radical form as the nth root of b. But if this is even and this is positive, you're going to get the plus or minus thing. So if n is even and b is positive, there are two real nth roots. The positive root is called the principal root. Now the reason for that is because in real life, it's pretty rare that we're going to take the square root of a negative, because that gives us imaginary stuff. So usually we want the square root to be positive so we can use that as we're solving real world problems. That's why it's called the principal root. And the symbol for that is just the nth root of b. But no, fourth root, square root, fourth root, sixth root, any even roots, you always have to do the plus or minus. Get two of those. And then mentions that if b is negative, there are no real nth roots. Wait a minute. Sixth root of negative 1. They're saying there's no number I could put in those slots, multiply it together, and get negative 1. Well, let's check that out. That's negative 1. Couldn't we put negative 1 in all of these slots? Wouldn't that give me negative 1? Why not? It's going to be positive. It won't work. So that's what they're saying, is that in the past, you know, we've worried about, oh, how are we going to write that as imaginary, blah, blah, blah. No, no, no. Now we're just going to write no real solutions. Can't do it. If we're taking an even root of a negative number, we're just going to write no real solutions. Can't do it. Because if you have an even number of slots to fill, it doesn't matter if your numbers are positive or negative, you're always going to get a positive number because two negatives make it positive. Can't do it. And then like it says here, kind of a silly one we're never going to use anyway, that's the nth root of 0 is always 0. Really? The square root of 0 is 0? Yep. Cubed root of 0 is 0? Yep. Because you have to have the same number in the slots every single time. So that's what happens. So now what? Well, there's some language that goes with this, some vocabulary. Because if you say, Cedar Home, that 3 is bothering me, and I look up here and there's a 3 here and there's a 3 here, I'm going to say, well, which 3 are you talking about? Well, inside that V is the index. That's the root that we want. So this is our nth root. And then this is, of course, the radical sign, whether or not we use it for square root, cubed root, fourth root is determined by the index. And then the radicand is the number underneath. So that's the fancy names that we have for them. There's index and there's radicand. Now the index gives the degree of the root. Degree is something we know from the other chapters, and it is just the highest power of the variable that we see as we're working through the problem. So same thing here. They're saying think powers to undo those powers, and that's what we have to get used to. So this says we are going to find all the real roots of these little bad boys. What are the real cubed roots? Can't help it. I get this visual in my head right away, and you should too, that we should be writing something like that, and that's the first thing we should do. Because right away that focuses my energy on, I need 3 of them. I need 3 of the exact same thing here to multiply to give me that. Now, I know what's going on. Some of you, your brains just turned off because you're like, decimals? I don't really want to do decimals in my head. Don't do that. Do it in pieces. If I asked you what the cubed root of 8 was, could you tell me what number needs to go in those slots to give me 8? What is it? 2. Now here's the second part. With decimals, whenever you multiply by a decimal, it moves one more place. Let me show you this. If I have 0.1, there it is, it's 0.1. But if I take 0.1 times 0.1, notice how now there's 2 positions after the decimal place? And if I take 0.1 times 0.1 times 0.1, I should not be shocked that there are now 3 decimal places. So if they all have to be the same, and each decimal place moves it over once, 1, 2, 3, how many decimals do each of these need? Just 1. 1 decimal place, 1 decimal place, and 1 decimal place. 1 for each movement that we need to get that into the 1000th position. So 0.2 times 0.2 times 0.2 will do it. And our answer would be 0.2. Any chance it could be negative 0.2? Cube root, 3 slots, 3 slots. All right, negative 1,000. Let's see here. Cube root of negative 1,000. It's a lot of zeros. What number do you suppose we need to write down in all 3 of those slots? 10? 10 times 10 times 10? That's 1,000. You're real close. Negative 10. Negative and a negative will make a positive. Then you'll have a positive times a negative, and it'll come right back to a negative. So this is going to be negative 10. Remember, with this one, it was decimal places. With this one, the trick is zeros. You need 1, 2, 3 zeros. You need 1 0 in each of these to make that happen. All right, now we're going to freak out at the fractions. No freaking out is allowed. Here's why. We're not going to think of this as the cubed root of 127. We're not. We're going to split it and say, okay, it's the cubed root of 1 over the cubed root of 27. So it's not such a big deal anymore. 3 slots. What do you put them in put in them to get 1. 1. Has to be. 1 times 1 times 1. 27. So think about it. It has to be a number small enough that if we take it times itself 3 times would give us 27. What is it? It is 3. Again, there's no chance that that could be negative, or they would have had us take the cubed root of negative 127. They didn't. All right, down here, 4th root. 4th root of 1. 4 slots. What would we get? 1. And what else would make it work? Negative 1, exactly, because if we put 1s in here, we'll get a 1. If we put negative 1s in here, we'll get a 1. So we need a little plus or minus. Remember, whenever you have even roots, we have to do that little plus or minus piece. Oh boy, this one looks scary. Four slots. Shelby, you shaking your head now? What's wrong with it? Can't take the 4th root of a negative number. We can't put negatives in here and get a negative. We're going to get a positive answer. We can't put positives in here and get a negative answer. It's not going to happen. So even root, negative, radicand, no real solution. Ooh, a fraction. 4th root of 16 over 81. So here's what we try first. Does 16 over 81 reduce? Well, I always use the calculator for that. Parentheses 16 divided by 81. Math number 1. Nope, we're right back where we were. 16 over 81. Well, maybe that's an okay thing. Because what we want to do is split this and say 4th root of 16 over 4th root of 81. What do we have to put in front of this answer? Plus or minus. This is 4th root, so it's going to be plus or minus something. 4 slots, something small enough that it would give us 16. 2. 4 slots, something small enough to give us 81. It is 3. Now, if you're sitting there saying, I'm never going to remember all of that root stuff, you will, but let me show you. Here's your backup plan. Your backup plan is for math, and look at number 5. Number 5 is really generic. It says whatever root you want, put that number in. So this would be the 4th root of 81. And we can get it. But that's not the best way to learn roots. It's not. The best way to learn roots is by a cheater slip. So what I'm going to give you right now we call a power chart. Because remember, radicals undo power charts. Know this, you won't be allowed to use this on the test. Let me get this handed out and then I'll explain why this is going to be so helpful to you. You know what happens with our brain when we punch something in the calculator? It shuts off. It says, you don't need me. You got a calculator to do this. I'm not going to do any work. I'm just going to write down what you tell me. There are times when we write down ridiculous answers because we are not thinking about what comes out of the calculator. And if we make a mistake, there's something goofy we're writing down, and we don't realize it's goofy because our brain shuts off. But if we have to look something up, we get our brain's attention. Our brain says, oh, you're making me look something up. This is a bother. The first time, yeah, you'll probably forget it within 30 minutes. The second time, you make your brain look the same thing up. Your brain says, oh, this is getting really ridiculous. Why am I having to look this up again? The third time, your brain says, okay, I'm going to hang on to this information because obviously this is something I knew. That's what this is for, is to train your brain. You, by accident, will memorize 4 through to 81. You will. It's just going to happen. So here's how you use your power chart. If you want the 4th root of 81, you go to where it says 4th power, up the top, and then you go find 81. And then use your finger to trace back to the left-hand side. It's 3. If we want the 5th root of 59,049. Do what I just said. Find the 5th power, go down to 59,049, and tell me the 5th root of 59,049. It is not. Now, we're not going to use practically all of this stuff over here. It's, really huge. Most of the stuff that we do in this class is probably the first 3 or 4 rows. But by accident, you didn't memorize it because your brain's going to get sick of looking it up. It is. So if you have this sitting next to you as you're doing your homework, your brain is going to start to think in powers. It just does. It can't help it. We can train our brain to do what we need it to do. If you use your calculator for all of these, you're not going to have a good understanding of powers. You just remember, in Algebra 2, you show what you can with algebra, and then this is backup plan. This is definitely backup plan here. And when you take the test, you're not going to get to use the cheater slip, and if you forget something, yes, use the backup plan. But try to think in terms of powers as we go through these. So now, here's what we're going to do. I am going to have you work through 1a, the got it here, which will be the 5th root of 0, and 1b, which is the 5th root of -1, and 1c, which is the 5th root of 32. Write down what your answers are, and when you're done, when you have those done, I want you to come up to this box and I want you to grab one of these whiteboards and go back to your desk with the whiteboard. Remember, if you need to, use the cheater slip. Don't grab the calculator if you can help it. Oh, and you probably want to put your name on that power chart because they get left behind quite a bit, and it's something you definitely want to keep. So write down your answers. Come up and get a whiteboard. Again, think of those 5 slots. Good, I already saw some people making the slots. Once you have your whiteboard, get that bag open on the side of your desk and grab that whiteboard marker and the whiteboard eraser. It's a marker looks white and then it has blue on the side, so it's a blue whiteboard marker. And the eraser's in there too.
Yeah, we never even used these one time. Now, so we're using them.
I told you, when we get to the spots where we can go bang.
Yes.
Oh, no. Oh, man.
Where's the markers?
They're in your bags.
Oh.
On the desk, yeah. Markers and erasers in the bag hanging on your desk. If it writes, it's good.
Apparently this is yours.
Oh. Everybody get a whiteboard? Got your bag open so you can get your marker and your eraser? Here's what I want you to do. I want you to write your answer to 1A, big and bold so I can see it, and hold your whiteboard up just to me. Nobody else needs to see it. Just to me. Not all 3, just the first answer. See, in a timid goose eggs. Zeros. It's the only option, right? Any root of 0 is 0. That's it. Write down your answer to 1b, fifth root of -1. All right. Those of you that have -1 up there, you are correct. Those of you that had no real solutions, you forgot one thing. It can be negative if it's an odd index, because we're writing it down in 5 slots. It's just if it's an even index. So if it were the 4th root of -1, we would write no real solutions. But if it's the 3rd, the 5th, the 7th, the 9th, then we've got a -1. Write your answer to C, the 5th root of 32, please. And let me see. Can it be both positive and negative on this one? 5 slots. No, because if we had a negative, it would come up to be a negative. So we've got 0, -1, and 2. So whenever you have the even roots, you have to think, well, that's the ones with the plus or minus. But whenever we have the odd roots, one answer. That's all we get. So B is going to switch gears on us because it says, what is the real square roots of 0.01, -1, and 36/21. So take a minute and write them down on your packet, what you think the answers to those are. Remember, this is square root this time, so it's an even root. 2 slots to fill. Write down the answers to all 3 of those. Now on your whiteboard, we're going to go one by one. Okay? Give me your answer to the square root of 0.01. And I want you to show them to each other. So that those of you that forgot, remember what it was you forgot. Plus and minus. Plus and minus. Good for you on the decimals, though. That was really good that everybody had that 0.1 in there. Write your answer down for the square root of -1. And show me on the whiteboard. Now, hold them up and flip them around so everybody else can check and see what you have. So what is it? Is it -1? Is it I? Is it no real solutions? It's no real solutions. Remember, we knew this is I in the past, but we can't do that in this chapter. In this chapter, we're only concerned with the real solutions. Square root of 36 over, whoa, that was 121, wasn't it? Write your answer down. I already see some people that forgot something. This is square root. Hold them up and show them to everybody. Some of you caught yourselves as soon as I said you forgot something. You forgot your plus or minus. Yeah, some of you caught yourself right away. Now, you're going to notice there were a few of these I had you show other people, and you're thinking like, oh God, those are the ones that was wrong. Why did you do that? You weren't the only one that was wrong, and we needed to talk through that so everybody remembers, hey, plus or minus, that's a big deal when you do that square root stuff, when you do the fourth root stuff, the sixth root stuff. Now, there was a part C up here that's kind of important. And part C says, explain why a negative real number b has no real nth roots if n is even. So, they're asking why, if we have 2 slots, or 4 slots, or 6 slots, or 8 slots, etc., why it can't be negative. Why can't it be negative? Yep. And that's what they're asking us to think through, is think through those slots. So let's see how we can put this. The question was, explain why a negative real number b has no real nth roots if n is even. So a negative number in any of those slots. Well, here's what we know about multiplying positives and negatives. Multiply an even number of positive or, and that's a big or because they would all be positive, or negative numbers and your answer will be positive. Every time. If we have an even number of slots, it doesn't matter if they're all negative or they're all positive. An even number of slots gives you a positive answer every single time. It has to. So, let's see. Rats. We're getting close already? Well, that's okay. 43210 me. I know you made some little mistakes, but overall, how do you feel about our nth root piece so far? Okay. And remember to keep that slip handy, that little cheater slip handy. And we already did that yesterday, and we didn't get far enough to do those two. So we're going to do section 6.1, page 364, 11 to 25 the odds, and then 32 and 34.